In this lesson, we're going to be focusing on calculations on dimensions. So this question number 1. It says, show that the following relation for the time period of a body executing simple harmonic motion is correct. Now for this relation to be correct, the dimension of this left hand side must equal to the dimension of the right hand side. Alright, so let's find the dimension of this period t and then find the dimension of root L over G. So this is constant and it does not affect the dimensions. We're only going to focus on root L over G. Alright, so the dimension of period, which is also known as time, is t. So left hand side has the dimension of t. Let's now find the dimension of this right hand side, that is root L over G. So we have root L over G. Now this can be written as root L over root G. Alright, and then root L can be written as L raised to power half. So the sentiment is applicable to root G, which can be written as G raised to power half. So this is length, and as we all know, the dimension to represent length is equals to L. Alright, so this is L raised to power half, and then over acceleration due to gravity has the dimension of L, then t raised to power negative 2. So we are going to raise all of these to the power of half. So we are going to have L raised to power half, then over. We are going to multiply this exponent 1 over half with this one because exponent of this L is 1. So we have L 1 times half is half, then minus 2 times half for this t is equals to t raised to power. Now this 2 is going to cancel this 2. It's going to be t raised to power negative 1. Alright, so this now is equals to L raised to power half minus half, this half that is at the denominator, then over t raised to power negative 1. So half minus half is equals to 0. So you have L raised to power 0, then over t raised to power negative 1. And then L raised to power 0 is equals to 1, then over t raised to power negative 1. Now 1 over t raised to power negative 1 is equals to t. So as you can see, the dimension of the right hand side is equals to the left hand side. So this relation is correct. Let's move to the next question. Question number 2. Deduce the dimensional formula for a modulus of elasticity. So the modulus of elasticity is equal to stress over strain. Alright, and then stress, as we know, is equals to force over area, then over strain is equals to change in length over the original length. Now if we simplify this, we are going to have F over A divided by change in length over the original length. So this is going to be F over A multiplied by, we are going to take this denominator to the numerator, so L over, then take this one to the denominator over change in L. So overall is going to be F times L over area times change in L. Now let's apply the dimensions. Now the dimension for force is equals to ml t raised to power negative 2, then multiplied by the dimension of L is simply L, that is length, then over the dimension of area is L square, then multiplied by the dimension of change in length, so it's also equal to L. So this is equals to m. Now this L times L will be L square, then t raised to power minus 2 over, we have L square multiplied by L. Now this and this will cancel. This now becomes m. Now this L here is raised to power 1. When it goes to the numerator, it will be negative 1. So you have ml raised to power negative 1 multiplied by this t here now raised to power negative 2. So this is the dimension for the modulus of elasticity that we're asked to find. Let's move to the next question. Question number 3. If the frequency of a stressed string depends upon the length of the string, the tension in the string, and the mass per unit length of the string, establish a relation for the frequency using the concept of dimension. So we write solution. So we ask that the frequency of a straight string depends upon the, now we are going to interpret this as frequency is directly proportional to, because it depends on, so the first parameter we're given is the length, then the second parameter is the tension T, and then the third parameter we're given is the mass per unit length, which is this lambda. So we have to establish a relation for the frequency using the concept of dimension. So we write F. Now this is a proportionality sign. To change this to equal to, we're going to introduce a constant. So let's call that constant K. So K times we have L, then T, and then this is lambda, which is the mass per unit length. So because we have to establish a relation for the frequency using the concept of dimension, we don't actually know the powers of these parameters, length, time, and this lambda. So we are going to assign x, y, z as their powers, and then solve for this value of x, y, z. So first, to start it, we are going to compare the dimensions of this frequency, that is the dimension of the left hand side, to the dimension of the right hand sides. So frequency, as we all know, is inverse of time. Alright, that's inverse of period. So if period t has a dimension of t, then f, which is the inverse of period, we have a dimension of 1 over t, or t raised to power negative 1. So we're going to replace the dimension of frequency with t raised to power negative 1. So this is t raised to power negative 1, then equal to, now we have k. Now this is length. Dimension of length is simply equals to length. So we have L raised to the power x, then multiplied by the dimension of this t here is tension, and as we all know, tension has the same dimension as force, so which is ml t raised to the power negative 2. So all raised to the power of y, then multiplied by this lambda, which was defined as the mass per unit length, so which is mass over length, or mass multiplied by L raised to the power negative 1, then all raised to the power z. So this t raised to the power negative 1 can also be written as m raised to the power 0, then L raised to the power 0, and then t raised to the power negative 1. Alright, so this thing I wrote is the same thing as t raised to the power negative 1, then equal to, let's collect like terms here. So for L, we have L into, then the powers is x plus y, because this one multiplied by 1 here will be L raised to the power y. Then for this one, L raised to the power negative 1 times z is L raised to the power negative z. So L will be, we have the powers of x, then plus y for this one, then minus z for this one. So for m is going to be, there's no m here, so for here m is going to be y, then for here is going to be plus z. Alright, then for t, for this side there's no t here, then here there is t here with a power of negative 2, so negative 2 times y will be negative 2y, and then there's no t here. So let's equate the powers of the left hand side to the right hand side. So the power of m here is 0, and the power of m here is y plus z, so it's going to be y plus z equal to 0. So for L, we're going to have x plus y minus z equal to 0. So we have x plus y minus z equal to 0, and then for t, we're going to have minus 2y equals to minus 1. So we have minus 2y equals to minus 1. So let's name this our equation I. This is equation II, and then this is equation III. Now from this equation III, we can find the value of y. So we have minus 2y equals to negative 1. Let's divide both sides by minus 2. So this and this will cancel. Y will be equals to minus 1 over minus 2 is equals to half, because this and this will cancel. So the value of our y is equals to half. So let's substitute y equals to half in equation I to find z. So when we do that, we are going to have half plus z equals to 0. If you make z source of the formula, the value of z is going to be minus 1 over 2. Alright, so we have that z is equals to minus 1 over 2. Then we are going to substitute the value of y and z in this equation I to find the value of x. So when we do that, we are going to have x, then we have plus y is half, then minus z is what? Minus half. Alright, so this is equals to then we have x, then half minus minus is plus, half plus half is 1, so we have x plus 1 equals to 0, and then finally we have that x is equals to minus 1. Alright, so we have that x here is equals to negative 1. So we're going to replace this x, y and z here with minus 1, half and minus half. So we have that frequency is equals to k into L raised to power x here is negative 1, then multiplied by t raised to power y here is half, and then we have lambda here, then raised to power z here is minus 1 over 2. So we have that f here is equals to k into, now this L raised to power minus 1 is going to be under as L, alright, then t raised to power half will be at the numerator because there's no negative sign there. This will be half, and then lambda raised to power negative half will appear at the denominator as lambda raised to power half. Alright, now we can say that our final answer is f equals to k. Now we can write this as 1 over L then into square root of, because this half signifies square root, so square root of t over lambda. Alright, because this t here is at the numerator with half, and then lambda is at the denominator with half, so they are the same thing as square root of t over lambda. So this is the final answer to this question. Please remember to subscribe to my YouTube channel, like, comment and share with your friends.